Okay, guys. So, Form 4 Chapter 2, let's just go through this very quickly. Definitions, these are things which they will ask you maybe 1 mark only. Okay, matter, mass, space. Keywords, okay? Matter is anything that occupies mass and space. Okay, it has mass and occupies space. Tiny discrete particles. These two together make up the definition of matter. So, this total definition here will be 2 marks here. Mass occupies space, 1 mark. Discrete particles, 1 mark. Okay. Now, matter got 3 forms. Okay. Solid, liquid, gas. Let's take a look at each one. I'm going to use 3 different colors, starting with solid. Arrangement-wise, they are closely packed, orderly manner. Liquid, closely packed, not orderly. Gas, far apart. Now, vibrate, rotate, fixed positions, move randomly and slowly, and last but not least, randomly, freely at high speeds. Keyword, key difference here is this is slow, this is freely at high speeds. That is the main difference between liquid and gas. Okay, next up, when it comes to solids, the force of attraction is very strong. Why? Because it's so close. So in chemistry, the closer two things are, the stronger the force of attraction. So for liquid, naturally it will be less strong, and gas will be the weakest. So I'm going to skip. Kinetic energy. Now, guys, kinetic means to move, okay? So when you are very close and the bond is very strong, you cannot move. The particles are stuck, okay? So low kinetic energy is solid. For liquid is medium kinetic energy because they're not that stuck, but they're also not that free. And then last but not least, gas. Gas is the highest because the force of attraction is very weak. So the weaker the force, the higher the kinetic energy. So look here, yeah. Force down, kinetic energy up, and vice versa as well, okay? Okay. Now, shape and volume. If it's a solid, confirm fixed shape. Cannot be compressed, okay? Try compressing your book. It's never going to work. Your book is a solid, okay? Now, liquid. Fixed volume. Cannot be easily compressed. For you to compress a liquid in like a hydraulic like pressure chamber, for example, this is your piston. If you want to compress liquid in here, it's not that easy. Solid cannot at all. Liquid can, but not easily. Okay? In fact, let me change the color. I used the wrong color already. Wait, See, liquids, fixed volume, do not have fixed shape. What do? They take the volume of the container. So whatever shape your container is, the liquid will follow. Okay? And last but not least, cannot be easily compressed. Gases do not have fixed shape and volume, easily compressed. Why? Because they don't have a fixed shape and they don't have a fixed volume. So if you have a lot of gas, it's harder to compress because the pressure is higher. If you have a little bit of gas, it's easier to compress because why? There's less pressure. So these are the major differences when it comes to the theory of matter, the states of matter, okay? This one, they can ask you in your paper 2 section B normally. To be honest, this is a very simple topic, so they probably won't ask you that much. It's mainly your understanding only lah. Okay, so I'm not going to bang my head on here for much longer. This one you sendiri have to hafal, okay? Okay, now we move on to melting point, healing point, boiling point and all that. Evaporation, when something is getting hotter, yeah? Liquid, heated, particles gain energy, move faster. Remember, heat energy becomes kinetic energy. Same thing from your physics. Now, continue heating, supply more energy, blah, 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 blah. Okay. Until, see, continued heating, supply more energy to what? To the particles, because you're heating them up. Until particles can overcome attractive forces between them. Means, right, if these two particles are held by a bond, you put heat here. The whole point of the heat is to break this bond so that the particles can go wherever the hell they want to go. Okay? The heat is to break this bond. Sebab as long as the bond is there, the particles are not going anywhere. So this evaporation process is when you take a liquid and turn it to gas. So if this is your liquid, this is your gas, this is your liquid to gas intermediary area. Okay, this is the part where you need to overcome these forces of attraction. Here liquid, here overcome, then here gas. If you guys understand so far, just drop a thumbs up. Okay, good. Okay, now at this point the liquid starts to become a gas. See, because of how much energy there is, because the bonds have been broken, the liquid can become gas. Remember, you don't overcome the forces of attraction, you don't convert from liquid to gas. As simple as that. Okay, evaporation takes place at all temperatures between melting point, boiling point. Okay. Now, for melting pula, solid heated, particle gain, kinetic energy. Same concept. By the way, this one not cair, this one liquid. The book got problem. Okay. So, gain thermal energy, absorb thermal energy, gain kinetic energy, vibrate more rapidly. Continued heating, supply more energy, particle, overcome attractive force. Break away. Particles move away from their fixed position. Why? Because solid to liquid, the process is known as melting. The whole point of solid to liquid is to increase the amount of kinetic energy so that it is no longer a fixed shape. It's no longer stuck there. It can break apart. Okay? So, once you overcome the force of attraction, it will move away from their fixed positions. And then, at this point, solid starts to change to a liquid. Temperature is known as melting point. Solid change to liquid is known as melting point. So, let me explain that using this graph, okay? Now, who here has seen this graph before? This is your naphthalene curve graph, that sort of thing lah. If you remember this graph, put a thumbs up. Okay, good. Now, when we look at this graph, let's imagine this is a change in phase, okay? I'm going to add more to the graph. Now, why am I adding more? This is purely a solid. Let's say my graph goes all the way up until maybe, I don't know, let's take a look at 120 maybe, just an example, okay? Okay, now what I want you to look at, from 61 all the way to 80, you are heating up a solid, yeah guys. This phase here is 50% solid, 50% liquid. Why? Because this is the temperature. This is the melting point. Now, you might be asking me, bro, why so long at the melting point? Like, why the fluid never move? Because at the melting point is where you need to overcome your forces of attraction. So the temperature stays the same. Temperature stays same. Heat energy being absorbed. Kinetic energy still the same. Because walaupun you are absorbing your heat energy, it is still not enough to increase your movement, your kinetic energy. Here, this part here indicates to us that we finally already break through the force of attraction. So this is our liquid. Our liquid is from 80 to 89 degrees Celsius. This right here means that we already overcome it, you know. The heat energy, we already absorbed enough. Now, instead of we absorb, but then the kinetic stays the same, now no. Now, it's back to here. The more you absorb, the more the temperature increase, the more the kinetic energy increase. Okay, until we reach here. 50% liquid, 50% gas again. Now, this 50-50 over here is known as your boiling point. Or your evaporation point lah. But normally people just say boiling point. Same thing. The same shit which you learn here, you apply back here. Guys, I'm going to be honest with you. Chemistry is one of the subjects, right? Whatever you write, if you know what you're writing, you can just rewrite the same thing. Because think about it. The temperature is stuck at 89. Temperature stay the same. Are we still heating it? Yes. Is the kinetic energy still the same? Yes. Just like here, guys. Once it pecah, then here from 89 degrees Celsius and above, you are fully in your gas phase. So these transition phases here are 50-50s where you need to overcome the forces of attraction by pumping in more and more heat energy. You guys can understand or not? If anyone is unclear, buka your mic. Don't worry, guys. I'm going to count to 3, by the count of 3, if no one says anything, I'm assuming you all are clear. Okay, 1, 2, 3. Okay, guys, this one, right, to be honest, let's take a look here. Like I said, from solid to liquid, liquid to gas, semua same concept. As in, it's all the same forces of attraction thing. If your graph is going downwards pula, it's going to be the same. You are in your gas phase. Now you are 50% gas, 50% liquid. Now you're in your liquid phase. 50% liquid, 50% solid. Then here you are back in your solid phase. Wait guys, I'll be right back. Give me a second. Okay, so now here pula, whatever you learn on top there, when you're going up, going down, complete opposite. So what is happening here? When temperature goes down, decrease temperature, decrease kinetic energy, yeah? Now, from gas to liquid is known as what? Look here. Condensation. Gas to liquid is condensation. So this is the process of condensation right here. What's happening? Your forces of attraction are increasing. Why? What I told you. When your temperature naik, your kinetic also naik. But when your temperature naik, your force of attraction turun. Look here. I wrote it here just now. See? Your kinetic naik means your temperature also naik, but your force will turun. Why? Because the temperature, remember, temperature doesn't form bonds, it breaks bonds. It breaks bonds. So when your temperature goes up, your bonds go down. So your forces go down. Now, your temperature is going down. So your force of attraction go up. Your kinetic energy is going down. Your temperature is still the same. for now. Why? Because you are in this phase here. You need to overcome this phase. You need to lose enough kinetic energy. Okay, sorry, this one kinetic energy same. Because the heat input needs to go down. The amount of heat energy you're putting in needs to go down. Now, while you are decreasing this will still stay the same. Why? Because it needs to rebuild. So, once it can rebuild, boom, tengok, it will go back down again. So, remember, this whole process here is you losing heat, you decreasing, you're getting rid of the heat. This whole process here, on the other hand, is you are putting in, you are pumping in heat. Now, if you can understand this, guys, if you can understand this, right, these two, this one you sendiri can baca. I don't need to waste my time and teach you all. Because at the end of the day, my way of teaching, especially my former students, they will know, one of them is in this class actually, I don't like to repeat. Janji you faham, you baca sendiri, cukup. Because there's no need for me to read what's on the screen for you already. You got eyes, you got brain, you read yourself lah. My job is to help you understand it. But to memorize it comes down to you guys at the end of the day. So, I'm just going to ask one time. If anyone here wants me to explain this melting, boiling, freezing, condensation, sublimation, blah, 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 just put a thumbs up right now. If you don't want, I will skip and I will go back to this experiment. So I'm going to count to 3. If there are no thumbs up, I'm moving on, yeah? 1, 2, 3. Okay, very nice. Okay, let us move on here. Classification of particles and matter. Guys, everyone at some point in their life, right, when they first started chem, they always screw up the definition. I'll make it very simple for you. Particle got 3 types. A particle can be an ion, it can be an atom, it can be a molecule. Now, when we look at iron, ferrum, or we look at gold, or we look at I don't know, give me copper, let's say lah. These are elements. These are elements. That's why we call it the periodic table of elements. Not elephants, elements. Now, this periodic table of elements, okay, for you to have an element, you need to be made up of atoms. So, iron atoms make up the element of iron. An iron atom and a copper atom are not the same. They are completely different. Yes, they are atoms, but they belong to different elements. Are we clear on that? If we are clear, can I get some thumbs up? Okay. Second thing, ion. An ion basically means if you have a potassium, this is a potassium atom because it's neutral. This is a potassium ion. This is chlorine. This is a chloride ion. Now, an ion differs from an atom in a sense that a pure atom is neutral. The charge is 0. An ion must be positive or negative. Lastly, molecule. Group of atoms chemically bond together. Guys, molecules, we got two types. Okay? Molecules. Where's the definition? I can't find it. Yep. Give me 1 second. Okay. A molecule means, right, a group of atoms chemically bound together. What does that mean? Chlorine is an atom. Chlorine is an element. But chlorine can never exist on its own because it's unstable. It is electronegative. So, since chlorine is electronegative, H2, H2O is a form of a molecule. We'll get to that in a bit. So, a molecule, right, basically means that the fluid must exist with someone. So like he said just now, H2O. H2O is a molecule, a water molecule, which is a compound. Now, what is the meaning of compound? Compound, two or more elements. We have the element of hydrogen and the element of oxygen. Two different types of elements, and here's the key, chemically bonded together. Now, that is if we have two or more elements. Is it a molecule? Yes. A molecule, guys, you see, a compound is a type of molecule. Now, if I were to draw it in a Venn diagram, M will be molecule, C is compound. So, compound is a type of molecule. It's under the subcategory. So, I want to explain to you the difference. Compound, two or more element. But a general molecule is something that cannot exist on its own. Like chlorine. Chlorine can never be alone. You will always find Cl2. Hydrogen, you will never find alone. You will always find H2. These are molecules. Oxygen, when do you ever see oxygen alone? You don't. O2. Now, you either find oxygen as O2 or contoh H2O. It doesn't matter if the oxygen is with another oxygen or the oxygen is with another atom. It has to be with someone. The oxygen can be gay. Maybe the fella likes his own kind lah. Sendiri wanna kacau. Okay. O2, dua-dua pun O, no problem. Maybe the oxygen is straight. It doesn't want to look for another oxygen. Hydrogen. But it doesn't matter. End of the day, you gay or straight, you're in a relationship. That is the whole concept of a compound. It does not matter if you bind to your own kind or you bind to something else. As long as you are binding, you are defined as a molecule. Compound is specifically more than one element, so two or more. Molecule could be just one type of element, could be many. So molecule is general, compound is specific. Molecule is only one type of atom, only one type of element, or maybe two type of element or three type of element. Compound, minimum two type of elements. Can you guys understand? Okay, good. I'm assuming everyone understands. Okay, let us move on. Yeah, over here. See? Molecule can be elemental or can be compound. See? A molecule could be its own kind Oh, call ends in 15 minutes. Uh-oh. I will have to make a new link after this. I also didn't know since when Google so code one. Guys, normally Zoom will give you limit or not? Can someone like on their mic and tell me the Zoom have a limit?
No.
Oh, so Zoom unlimited, huh?
Yeah.
Okay, so for this class, I'll make another Google Meet link, but next, moving forward, we'll use Zoom, okay? Alright, so, like I said, we can have an elemental molecule or a compound molecule. So, this one, the definitions, guys. Normally, I noticed this Pelangi brand, this book, when they give you SPM tips, right? Hafal. It's pretty damn useful. And one thing about my class, if you see me put a star, it means I want you to pay extra attention to it. Because it's something which may help you more than you can imagine. Alright, then do you guys still want me to explain naphthalene, or you guys want me to move on from naphthalene? If you want me to move on, spam thumbs up. Okay, nice. Okay. Choose the cooling temperature. Okay. Which statement is correct about substance S? Alright. X is a gas at room temperature. That's impossible. Why? Because at room temperature, it's undergoing a phase change. See? B. You dah tahu. Confirm B correct. It just came out of my mouth. I just said it. See? Physical change. Phase change ke physical change? Same meaning. Because the three phases are solid, liquid and gas ma. Same thing here. Physical change. So the answer is B. Okay. Now, I'll teach as much as I can within the next 10 minutes. Then I have to make a new Google Meet link. Or maybe one of you start a Google Meet link and you send. I'm not sure if it's like limited to like 1 hour per person or not. I'm not sure. But yeah, hold on. Let's go here. Proton, charge 1, mass 1. Neutron, charge 0, mass 1. Electron, charge -1, relative mass cacat. So whenever you see this type of cacat number in exam, you know it's electron. Okay? Proton, neutron, mass is always 1. That's why we talk about relative atomic mass. Atomic mass is made of protons and neutrons. So this is your atom. This is the nucleus of your atom. This nucleus contains this. And look here, like what I just said. Almost all the mass is concentrated here. So your atomic mass, the mass of your atom, is determined by your nucleus. Now, why is it positively charged? Guys, if I have 6 proton and 6 neutron, let's say we're looking at carbon, yeah? Carbon has 6 proton, 6 neutron. 6 neutron, so 6 positive 1. Plus my 6 neutron. Neutron 0. Of course, my charge is going to be positive lah. If my neutron, which is impossible by the way, it is impossible for your nucleus to not be positive. It has to be positive. Has to. That you will never, ever in your life find a neutral nucleus or a negative nucleus. If you find your nucleus neutral or negative, Either the question got error or it's a trick question. They're trying to bullshit you. It is impossible. Electron, negatively charged. I'm not going to teach you this move in specific shell thing because when you come to uni, like for those of you who are going to end up taking medical related, you do foundation in science, this is fake. They do not move in shells. They move in their own way. I don't need to confuse you all so much. Very small mass, negatively charged. Number of electrons, same as number of protons. Let me add on. You all also add on. In a neutral atom. Because guys, if we look at potassium, contohnya lah, potassium 2881, 19 electron. Potassium, not ion, potassium atom, like this. 19 electron. Potassium likes to donate. So this fellow will lari. Remember, it's saying here, when it is neutral. When it is neutral, your proton electron sama. So 19 electron, 19 proton. But now, in ionic form, you will have 18 electron, 19 proton. This is where you get your charge from. Because 19 positive, 18 negative. So you get positive 1. I bet not a lot of teachers would have taught you this. Now we look at chlorine, contohnya. 287. Kan? Correct. 287. 17. 17 electron, 17 proton. This is a chlorine atom that is neutral. Chlorine is electronegative. It loves negativity. So it will become chloride ion 288. You will get 18 electron, 17 proton. So 17 plus negative 18. That's how you get your charge, negative 1. Do you guys understand or not? So, remember, this is key, in an atom, in a neutral atom only. This will be the same. This will be the same. Kalau you cakap pasal ion, confirm there will be a difference. If we are clear, can I get a thumbs up? Chun. Guys, all this matu mandai here, you memorize yourself. I'm not going to waste my time explaining to you who these old people are. Because this one come out also, it will just come out in your section A, your MCQ, your ABCD. They'll just ask you, oh, this one is which structure, this one is whose structure. 1 mark only lah, guys. If you ask me, I never studied this during my SPM. It was a waste of time. So if all these matu mandai you want to hafal, go ahead. But for me, waste of time lah. Okay, guys, let's see, hold on. Guys, I need to off the meeting in a little while. So, how about I give you all a 10-minute break? Then 9 o'clock I make a new link. You want or not? Okay, but we have about another 4 minutes left before I have to off the call. So, guys, from 2.1, 2.2, shoot your questions now. Don't hold back, don't be shy. I know Rishabh won't be shy one. Rishabh the flow okay ni. Whenever I need him, whenever he don't know, he'll ask. So, guys, we have like another 3-4 minutes before I have to off the call. Open up and like how to say? You got a question? Shoot now. Really, no questions, guys. Okay, then how about some of you? Give me open and honest feedback about the way I teach.